Hello, today is 8-3. We are still looking at the difference between means, but today we're doing dependent samples. So if you remember our discussion in 8-1, independent samples are when there's two populations that you're looking at that you're comparing, and you take a sample from each of the populations to compare, and the samples are unrelated. A dependent sample is the same scenario, but you are taking a sample that is related. So it could be like your first sample is mothers and your second sample is their sons, and you're looking at some correlation between that mother-son relationship. Or it could be you're taking one sample and you're testing that sample before and after a situation. These are examples of dependent samples. For most of your problems in this book, they're going to be dependent samples with the before after idea. So huge tip in how to tell if you are looking at a dependent sample is you're going to, first of all, most of them are in a chart form, but you've got this happening right there, before and after. Okay. So these words in your chart, before and after, that's a really big clue that you've got a dependent sample. That is not always the case, but it often is the case. So it's kind of like when you see percentages, you think binomial, it may not be binomial, but that's a pretty good check to look. So same kind of idea here. You're going to set things up for the most part the same. We are going to look at the claim on this problem, and we're going to write that. So a physical therapist claims that the use of this therapeutic tape reduces pain in patients with tennis elbow. So they're going to test that. They're going to take a set of patients. They're going to test them before and then after using this tape. Is there enough evidence to support this claim? All right, so the claim, first of all, is that the use of the specific type of therapy tape reduces pain. So that means that if I use it before, I will have more pain than if I use it after. Okay, so if it reduces pain, that means that before taping is going to be bigger than after taping. All right. So this is your claim. Your complement of that is flip the sign, throw an equals on there. The equals one gets the H naught. The not equals gets the HA, and the HA dictates the picture. So because HA is pointing to the right, this is going to be a right-tailed test. All right. Now, this is where there's a slight change because we are a dependent sample. What we're trying to do is we're trying to gauge the change in people's pain level in this situation. So we're not really comparing before and after. We actually want to say, how is this changing? And so what that means in math is when I look at change, that means I'm looking at the difference between the two, or I'm subtracting the two. So I had told you that notationally, your book sometimes subtracts this mu sub 2 over to the left. On these dependent samples, we will always do that. So I'm going to take my claim, which is mu1 is bigger than mu2, and I'm just going to subtract mu2 over to the left. So this now becomes mu1 minus mu2 is greater than 0. These guys cancel out. Okay, I know for some of you that's challenging math. It's always going to look like that, though. You can just always take that mu2, move it to the left, and make it minus, and it's always going to be 0 on the right. Okay, so if you need to just kind of remember that system, you can do that. A lot of times we call this the difference of the means, mu sub d. You do not have to use that notation, but that is sometimes used. So all of these, this one, and my original claim are all the same, different formats for doing that. Okay, but This is also going to give us a clue to how we're going to do this problem. So obviously we've been given data. So we are going to enter this in our in a list. So on the TI, I want you to go to stat, go to edit, and I want you to put the before data in L1. This is going to be our before. And in L2, you're going to do your after. Now, can you switch them up? Absolutely. But then that switches up the direction of your claim. So however you decide this, you just have to stay consistent. I have decided that my before is going to be my first, my mean one. Okay. And the after is going to be 2. So that means I'm listing before in L1, after in L2. For my class calc people, you're going to come over here, and I've already entered this for you, but you're going to see right here, I'm naming the first list A and the second list B. Okay. Now, what we're going to do, like I said, we want to know the difference. We want to know the change in their pain level. And so what we're going to do is subtract these two lists. On class calc, what you do is we're going to call this a new list. So I'm going to call it C. So I'm going to tap and hold 9. Okay. And I'm going to hit my equals button. But now instead of actually having to subtract the lists like 7 minus 6, 7 minus 5, 4 minus 1, those entries being subtracted, what I can do is I can just say, I want to subtract all of list A minus all of list B. Okay. And the calculator knows, yeah, we're subtracting all the entries in here, and it's creating a new list. Now, if you look at this, look at that. So, oh, whoops. I think that's not supposed to be a 30. It's supposed to be a 3. There we go. Okay. So look at our list. I've now got a 1. What is that 1? Well, it's 7 minus 6. That first entry minus the first entry. And then 7 minus 5 is 2. And that's the second entry on my difference list. Yeah. So some of these are positive and some of these are negative. So, you know, a positive subtraction is going to mean that your pain went up. A negative is going to be that or excuse me, the positive is going to indicate that your pain went down because of the order we're subtracting, and negative is going to be that your pain went up. Okay. It doesn't matter. The positives or negatives, you don't have to pay attention to that. That's just an explanation of why. Sometimes the bigger number's on the top, sometimes it's on the bottom. Okay. So this now is the list that we're going to run our hypothesis test on, because the hypothesis test is making a claim on the difference between the change in the pain level. All right, let's jump over to my class calc people and show you how to do this on class calc. After you've edited your two lists, we're going to stay in this menu right here where you've got your lists, and we're going to go over to, I'm going to draw this a little bit bigger so I can write everything in it. So L1, L2, you've got your data, right? So now I want you to go use your arrow buttons to go over and highlight L3. So that means that you have to go over to L3 up till the blinky lights on it, and then you have to hit enter to actually get that black square to highlight it. And when you do that, well, first of all, if there's numbers in there, I want you to hit clear and then your down button. Okay, so that list is clear. And then go back up and highlight L3. What you'll notice is at the bottom, when this L3 is highlighted, at the bottom of your screen, you'll have this little equation bar, L3 equals. So what that's waiting for is, hey, do you want to put an equation in here instead of actually entering data numbers? And what we want to do is we want to take list 1 minus list 2. So you're just going to, with your highlighter up here at L3, you're going to do second function 1. That's going to give us L1. And you should see that appear down here when you type that. And then minus, so do your minus sign. And then you're going to go second function 2. And you should see your L2 show up. and then you're going to hit enter. And you should get a list of numbers. Okay, 1, 2, those are the differences that you saw on our list C on class calc. So you are going to be operating in this hypothesis test now with L3. That's the difference, the change in the pain. Okay, that's the calculator work. So now what do we do with this? Well, as I scan through this problem, I'm seeing that, let's see, the table shows the pain level, scale of 0 to 10. I've got 15 patients, and I've got an alpha value. What I'm not seeing is a population standard deviation. So since there's no population standard deviation, that means that I'm doing a t-test. I know that because I know I'm doing I'm comparing the means, so I know it's not a population proportion, and I know that I don't have a population standard deviation, so this is a t-test. And is it a 2 sample or 1 sample? Now think about it. It's not a 2 sample because this is dependent. We're actually looking at the total change in pain level. So this is a 1 sample on your 3rd list that you created. My class calc people, we're doing a 1 sample test on your on your list C, and my TI people, we're doing a 1 sample t-test on your L3 list. All right, so go to your t-test. For my TIs, remember, you are going to go stat over to tests, and I think your second option is going to say t-test, and you are going to select data and the list that you're going to enter when it asks you for your list is going to be L3 because that's your difference list. Okay, your mu naught is going to be 0 because that is what this number is. This is your claim. So we're always comparing it to 0, a positive change or a negative change. So mu naught is going to be your 0. Your list is going to be L3. Again, leave frequency as alone, and then pick your right-tailed test and push enter. For my class calc people, we're going to go down here below. It has to be below the list you've created. Class calc only registers the list above it. So we're going to click below this list C. I'm going to go into stat, into tests, and I am doing a t-test. All right, and I am going to pick data. So I want to know what's my mu. That's your 0, okay, in your claim. And the list, my list name is C. My p-values, I'm going to pick the right hand, and I've got, looks like 1, 2, 3 zeros and a 3. So my p-value is like this. It's very, very small. If my green is my alpha, alpha is 0.05. This is going to be, the p-value is going to be way smaller than my alpha. Now, if you're asked for your critical values, let's look at that. From class calc, my standardized test statistics going to be 4.38. That's on your TI too, 4.38. Whoops. Okay, and then we want to know, how do I find my critical value, my T critical? Well, that's going to be your inverse T on your TI, and it's going to be your T distribution, stat distribution, T distribution, My degrees of freedom are one less than my sample size. My sample size is 15, so I'm entering 14. That gives me my specific T curve. And then I'm going to go back into stat in distribution, and I'm going to do this dot inverse, because remember that's, hey, I've got an area and I want a value. This measures from the left. So if my alpha value is 0.05, what I'm going to enter into my inverse CDF is 0.95 to get my critical value. And there we have it, 1.76. So this T critical is 1.76. So whether you're comparing the P and the alpha or the standardized test statistic, which we usually just call T or T critical, the sample is way in the tail. So that means that we are going to reject H naught. Okay, so if my claim is HA and I reject the opposite, that means there is enough evidence to support the claim. And if you look down here, here's my reject H naught, my claim is HA. There is enough evidence to support the claim. If you want to use the chart for that, that's great. And that's all you've got for these problems. That's it. Okay, so let's just recap really quickly. You are going to still make your claim and your complement the same. Label H naught, HA the same. You're going to draw your picture the same way. The only difference is you're going to subtract over your mu2, and then you're going to use a single t-test on your third list. You're going to take list 1 minus list 2 and do a single t-test on list 3. Now, the book sometimes, when it talks about your list 3, so list 3 or list C for my class calc people, right? So this is your list 1 minus list 2, or your list A minus list B. Sometimes the book uses this notation. What they mean by that is the sample mean of your third list, your subtracted list, your L3 or your C. Your calculator still is just going to call it X bar, but sometimes the book delineates and calls it D, so it knows that, hey, I'm talking about the list that's the difference of the two, not the original two lists. And likewise, sometimes your book will use S sub D for the standard deviation of the difference, but your calculator will still put S sub X. So I just want you to be aware of that. I will be using these notations that your calculator uses, but I want you to be aware when you're looking at the book and the computer that sometimes they use that notation, and that's what they mean in that scenario. That's all for today. Thank you guys for tuning in. I will talk to you later.